Hello students, good morning. Welcome to our online classes. On continuation of our previous classes, in this class we are going to learn a new topic and interesting topic. At the most, it is a very useful topic in our electrical field, in any industry or in our electrical substations. The most important equipments are instrument transformers. Already you have seen what do you mean with the transformer? Two winding transformer, auto transformer, generally used in our laboratories and in electrical fields. The same principles can be used in our measuring and protective purpose in our electrical field. So, we are going to use CTs and PTs. Dear students, it is a very interesting and easy topic. Please carefully observe it. It is very essential to every electrical students. Okay, let us see what you mean by the instrument transformers. In this class, we are going to concentrate mainly on instrument transformer. What is the meaning of instrument transformers? What is the need of this instrument transformer? And classification of instrument transformers. In that, how current transformer used and how it will works in electrical field in case of protection and measurements. Similarly, how the potential transformer can be used in electrical field to measure the high voltages, and what are the precautions should be taken while using instrument transformers. So finally, we are going to compare these two instrument transformers, that is a CT and PT, and lastly we are going to know some few practical applications of these instrument transformers. Okay, so let us see these instrument transformers, how plays a vital role in our electrical field. So before that, there is a one quiz for you, because already in known transformer, single phase transformers and three phase transformers. At the same time, you know that the instruments also in voltmeter and the moving coil instrument and the moving iron instruments, whether it is a voltage, voltmeter or ammeter, how to extend these ranges for measurement of more current and more voltages. In previous classes, we have learned small voltmeter and ammeter can be used for measure the higher ranges values with the help of what? Shunts and multipliers. Where it is not possible to use this shunt and multipliers to enhance the range of our small existing voltmeter and ammeter, and we can use these CTs and PTs. Okay, so how we are going to use? Why can't use the and multiplier and the shunt? What is the extra benefit by using the CTPTs? Let us see. So you are going to get these answers by observing these small topics. Okay. So let us do. So you can see here figure itself. So this is a PT, potential transformer. Okay. This is a CT, current transformer. The PT will measure voltage and CT will measure the current. Okay. This is a two basic instrument transformers used in our electrical field. Before that, I want to ask few questions based on your previous knowledge. What is that? Now, can we use a 0 to 5 volts small voltmeter to measure the 100 kilovolts? Yes or no? What is your answer? Here I have the small voltmeter. Is the range from this to this one. So from this one, this to 0, 1, 2, 3, 4, 5 volts. Okay, 5 volts. Now, can I use up to maximum 5 volts? Can I use for voltage that is a 100 kV voltage? That is equal. Have you observed this 100 kV means it is a nearly tower voltage. Okay, this is a tower voltage nearly we are going to measure. By using this voltmeter, can you measure what is the voltage between these two R phase and Y phase voltages? Can you measure this one? I am asking this question. Will you measure? Why not? We can use it. What is the answer? Yes, we can measure. That means here I have the one idea. Have you seen any time God? Just ask to nearby your priest or mullah or baba. They will ask only, yes, why not? I can see my preacher, my guru in my mind. Will you show how this your God? If you ask the question, they will tell that. Have you find ghee in a milk? In raw milk, will you find ghee or butter? No. It requires some process. Milk has to heat it and it becomes to the cooled and becomes to the curd. After that, chilling this curd, we are going to get this butter and ghee. That means we require some process is required to get the required output from the raw value. Similarly, so if you want to see the God, you require some meditation and preparation is required. Preparatory work is you have to done it. Similarly, this small this voltmeter, small fellow, will it measure the voltage of the transmission voltage? This is less than 5 volts, very 5 volts. That is just like you see some cell battery voltage. It is capable to measure this voltage. If I use this purpose, this voltage, what will happen? Directly if I use this my voltmeter to measure this voltage, it will burn completely. And at the same time, you are trying to measure the voltage across these two terminals with the help of our small voltmeter. This meter will burn first of all, after that you may be burn. Sir, he told that how can you measure this voltage? You are told the answer is yes. So I am going to measure this voltage with the help of one instrument that is known as the potential instrument, PT. I require some device. So what has happened yesterday? There is one miracle. So Brihaspati and Saturn in same axis. Have you seen in night? So most of the people observed with the help of the telescope. Here the telescope is one device which can see the longer objectives. Similarly, I want to measure the current in these lines, voltage in these lines, between the two lines. I require some instrument is required, that known as instrument transformers. Whatever the high voltage and a high current can be measured with the help of our instrument transformers, and those which can convert higher voltage and a higher current to the smaller values, and the smaller values given to the input to our small meters, and correspondingly we are going to calibrate this all things. Okay, so that purpose I require the one additional instruments, additional equipment is required to measure the voltage, that is known as a PT. Because 100 kilovolts is a high tension voltage, HT voltage. Just you cannot approach nearby this 1 feet to know the know the differential potential between these two R phase and Y phase voltage. So HT, high tension voltage, you may get the induction effect. But we can measure this voltage, whether this voltage is 100 volts kV or 132 kV or it may be 80 kV. I want to know, I can measure with the help of a small voltmeter in addition to our instrument transformer. Okay, so this is a brief idea. Now, so well done. So you tried good. Next, another question. What is another question? Now here we can measure high voltages with a low range voltmeter with the help of a dash. Just we discussed. What is that one? Whether it is a shunt, potential transformer, auto transformer and current transformer. Which one we are going to measure? Okay, so what is the question? We can measure high voltage, HT voltage with a low range voltmeter. So I have the one voltmeter. This is a range. So the range is from 0 to 10 volts. So I want to measure the voltage across these two lines. It may be nearly 10 kV or 11 kV, just like 11 kV voltage. So I require the one media is required in between this one and this one. This is known as the instrument transformers. In instrument transformers, whether you are going to use the potential transformer or current transformer. So here, what is the range? Voltage. You are going to measure the voltage. That purpose I can use this only, potential transformer only. Shunt, where this is used to low measurement of currents in ammeters. And auto transformers can be vary the voltage only. And whereas the current transformer can be used to measure the current. But he is asking voltage range. The voltage range, the potential transformer. That means whatever your small voltmeter connected to the potential transformer and the potential transformer is connected to the HT lines. Okay, answer is which one answer? The potential transformer. Okay, so well right. Now coming to the another question. So now you can try it. We can measure high current with a low range ammeter with the help of a, already I told you. What is that one? A, whether it is shunt. Okay, this is a, okay, already I revealed it. Okay, whether you are going to a shunt, potential transformer, auto transformer, a current transformer. Please write. So here what is asking? Here he has a small ammeter. You want to measure, for example, 0 to 5 amperes in domestic application. But this ammeter can I use to measure the, what is the voltage? The current nearly 100 amperes. If I use it directly to measure the 100 amperes with the help of the 5 amperes ammeter, then automatically it will burn out. But in between I require the some media person is required, some broker is required here. Our media, what is the media? Whether it's a shunt or it's the potential transformer or auto transformer and current transformer. Which one you are going to use it? So already we have seen the shunt can be used to measure the extent, the range of ammeters in low ranges. And the potential transformer used to measure the extent, the range of voltage. And auto transformer is used to enhance the change, the vary the input voltage to the device. Whereas current transformer used to measure the high current, that is, this is known as the CT. So you can see current transformer is nothing but CT. That CT, how it looks CT? It looks the CT, this one. Okay, the CT, this is a CT can be used in 11 kV line or 33 kV line, or we can use up to the 132 kV line also. Sir, I want to the 220 kV, then what is the kV? So I can use that also, but increase the insulation from the base to this one. So once voltage increases, insulation, the insulators gaps should be increased more and more. Okay, this is a live, this is the earthed, this is the line. Now what is the answer now? Answer is the D. Okay, these are the some interesting questions. Now you are familiar to measure the higher voltage with the help of low range voltmeter. So we are going to use potential transformer. Now I want to measure the more current, high range of current with the help of current transformer. So this current transformer and potential transformers, both we can say instrument transformers. Okay, so what is the benefit of this instrument transformers? Now already you have the experience. Okay, so let us see instrument transformers. Instrument transformers are high accuracy class electrical devices used to isolate or transform voltage or current levels. Okay, what is the meaning? The instrument transformers are high accuracy, it will give the accuracy values. And a class electrical devices used to isolate or transform voltage and current levels. So what is the level? High level voltages, high level currents. So we are going to isolate from these levels. In between ourselves and high levels, there is one media presence in between two. So that is known as the instrument transformer. The most common usage of instrument transformers is to operate instruments or metering from high voltage and high current circuits, safely isolating secondary control circuit from the high voltage or currents. What is the meaning? So that means here there is a one tower. Let us assume this is a one tower. Okay, so this is the tower. And this is a one limb, this is a one limb, this is another limb. Okay, so this is a tower. So for example, this is the R phase, this is the Y phase, this is the B phase, and there is a lines. generally lines will flows. So this is the line, so which is going, this line is this line and this line. Now I want to measure what is the current in Y phase. So I want to connect the one ammeter has a two terminals, first terminal and second terminal, one terminal connected here and the terminal connected here. So that means whatever the line I want to know the current, I have to break it and I am going to connect here, I am to connect here. So but this line is carrying the currents of 100 amperes. So but our instrument resistance is a very low, less than 1 ohm. If I connected in series to this line, our meter will burn first of all. Suppose I want to measure the voltage between the two lines. So if I connected the voltmeter has also two terminals which is connected across the two points where we are going to measure the potential difference between the 2 points. If I connected voltmeter in between these two lines, so it will burn out. Okay, that purpose I am going to take the help of some instruments. Those instruments are instrument transformers. Instrument transformers. The instrument transformers are two types. One is a CT, another is a PT. CT means current transformer, PT means potential transformer. The current transformer can be used in case of it helps to measure the current values in high range circuits. Whereas potential transformer, name itself, it measures the potential, that is a voltage in high voltage lines. So what are the high ranges values converted into smaller values, the smaller values given to the low range instruments, that is whether it is ammeter and voltmeter. Okay, now another is the primary winding of the transformer is connected to the high voltage or a high current circuit and the meter or relay is connected to the secondary circuit. Dear students, here our instruments are used two purposes, not only one purpose. What are the two purposes, sir? One purpose is, this is one can be used to measuring purpose, that is not measuring purpose, that is for instruments, measurements, we can say the measuring purpose. It is connected to the instruments which will indicate the, oh, this is the voltage, so that is 110 volts or 120 kV it will gives. And so at the same time, okay, 10 amperes or it is the 53 amperes, it will give the instruments values. And at the same time, it will use it to protection purpose also. Protection. That means whenever the lines fallen on the ground, there is a earth fault, then short circuit current, high current will flows. The voltage will reduce, current will increase. How much voltage decreased, how much current increased in the short circuit line, I want to know. Then I can use these measuring instruments. Whenever the fault occurred in the system, I want to protect it. I want to isolate. I want to separate this faulty section from the healthy section. So I cannot measure always these currents continuously, the 24/7 time, because our lines are very number of kilometers. I cannot concentrate on along the line. So the fault may not avoid. Suddenly there is the heavy gale and wind comes. There is some trees may be fallen on our lines. Our lines maybe breaks and one line fall on the another line, or total lines fall on the ground. These are the faults. The faults already you know, the symmetrical faults and unsymmetrical faults. That is a LG fault, LGG fault, triple L faults. So symmetrical faults and unsymmetrical faults. Any fault that will give the abnormal values, whether it's current or voltage. So what will happen, sir, if occurred more current or more voltages? That will spoil all devices which is connected to that line. I think you may get some experience in your domestic. Sometimes what will happen, some lines may be getting high voltages. Sometimes you may be observed, sometimes your fan rotation will be more and your illumination of the tubelight may be more suddenly, or suddenly dim, suddenly normal. So during this process what will happen, some of the equipments may be fails. Some may be your TV or fridge may be burn out. So what is the reason? Due to the flickering of voltages. The more voltages and more currents, the all equipments which is connected to the line at that instant may be failure. So avoid that failures that may be occurred at any time while you are deep sleep at 12 o'clock. Suddenly one line maybe breaks. That maybe leads to high voltage in the line. That may be the failures, the insulation of the equipments, and that indicates, that leads to spoil that equipment. But I want to protect my all devices from this abnormal voltages and currents. That's why, so you might have observed in TV and fridge and costly equipment in our domestic, we are going to use it stabilizers. Have you observed the stabilizers? The stabilizers which will stabilize the voltage. If the low voltage comes, it will give the constant output. If high voltage will comes, it will give a constant voltage. Okay, so that is the help of the stabilizers. Now you can see this all in the next classes. Okay, now have you seen these instruments at any time? What are the instruments? Have you seen this? What is this one? What is this one? This is a tongue tester, clamp meter. What is it one? The clamp meter. Clamp meter. What is this one? So previously I want to know that the current in the line. So I am going to find, connect, open it and cut it, connected here. I am connected the one ammeter here. So it will measure the what is the current in the line by ammeter. But what has happened? I want to cut it. So if I use this my clamp meter, simple without cutting. So this whatever this one, so placed just like here. So then automatically that will gives the what is the current flowing in the conductor indicated in a digital mode or analog or digital. Okay, so this is nothing but it is the clamp meter induction principle. Okay, so generally you might observe in our laboratory. Now suppose if you are observed in our college, sometimes we are going to use a CTs also to measure the what is the current for our institute. So the current may be nearly 50 amperes, 50 amperes or 100 amperes sometimes while doing the all works in laboratories, different laboratories. In our houses, so maximum current is maybe less than 10 amperes, all appliances. But our workshops, in our college, our institutes, so we are going to use the different machines and different labs. So at a time we are going to draw the 50 amperes. Then how to measure this 50 amperes or sometimes 100 amperes? So that purpose I am going to use this one. So you can see it, the small CTs, R phase, Y phase, B phase, 3 CTs, and another is a neutral. Whatever the cable is going, just I connected the one coil. You can see this a coil connected, just is a this one placed here, no cutting, and it indicates, that means it acts as a primary, it acts as a secondary, just like this is a transformer effect. This is the primary and this is the secondary. So this one act as a line, act as a primary, and whereas this act as a secondary. Then so without cutting these cables, I can know what is the current flowing in the cable with the help of our CTs, small range CTs. Maybe these ranges may be 20 amperes, or sometimes we can say 50 amperes. Okay. Now suppose, sir, you may have some doubt. Sir, this cable has 50 to 100 amperes, sir, in our institution. Okay. Suppose I want to know that the total current in my village itself, total village itself. My village may be having the agricultural pump sets. My village may be having some rice mills, industries, and my village may be having so many domestic houses. Okay, I want to know that what is the current. If our institute itself will take the 100 amperes, then how much current will take this total village? That may be nearly 200 amperes or 300 amperes. Then how we are going to, whether I use this one or different thing. Or suppose this is my village. I want to measure the total mandal. I want to measure the total mandal, some 10 villages or 20 villages. Suppose I want to measure the total division, or I want to measure the total district. Then what is the current range and what is the voltage range? How can I use this CT, this one, sir? That purpose I can use another device. What is that one? You can see here. These are the CTs. Okay. So here for small purpose I can use this one. It's a portable, and here I can use in small industry, rice mill, and this can be used for the large populated thickly loaded area. This is known as the CTs. So R phase, Y phase, and B phase, another phase is connected here. Okay, so CTs, by using the CTs, I can measure whatever the value may be. It may be higher voltage and a higher current. So CTs are generally used to current transformer that will measure the current only. It will measure nearly 1000 amperes also. So based on the current, the size of this instrument changes. Okay. So how this one? So dear students, whether after this instrument, it is connected to simple our voltmeters only, these instruments which has the low range, and is connected to the small voltmeters. Where is the ammeter? CTs are ammeters. Here I can use the same ammeter, can be used. So small ranges 0 to 10 amperes. This 0 to 1 ampere. I can use this one ranges. I can use this ranges. So whatever the current flowing in the primary, that is converted in the secondary into the less value that is given to our instruments. Our instruments will take that values and indicates the corresponding what is the current flowing in the primary, just such a way that we calibrated our instruments. Okay, so you can see the voltmeters and ammeters generally used in our laboratories. So you can see what is this one? This is a voltmeter, this is a ammeter. Voltmeter used always connected parallel. Okay, is ammeter always connected in series. You know that ammeters having the very low internal resistance. Resistance is a very low, whereas this has the high resistance. Hence, we are connected in parallel across the two terminals, but it is the low resistance. It should be connected with the help of load resistance always, because already you have seen. So, antibiotic capacity is a very low, that is the resistance very low, whereas antibiotic capacities are more for the coronavirus. Hence, it is connected in parallel, it is connected in series to measure the current, to measure the voltage. Okay, these are the different ranges of ammeters and voltmeters. So, let us see our topic now. So, what is the time now? So, half an hour is over. Now, see, what are instrument transformers? Now, we have seen. Instrument transformers are low power rating transformers. It is used to extend the range of measuring instruments, and not only measuring instruments, and the measured value given to our protective equipments, the protection circuits, and at the same time it is used to provide isolation from the high voltages. So, for 220 kV and 400 kV and maximum 765 kV also measured with the help of our potential transformer in a small voltmeter. Okay, now what is the need of these instruments? Now we are required, essential. So, I want to measure the voltage in a towers, HT towers. I want to measure a large village total current. Then I required these instruments in between these large HT voltages and our small meters. So, what is the need? Now, to provide isolation from high voltages and application of single instrument for various range measurements. Same meter can be used at different voltage and current ranges by changing its CTs and PTs ranges also, and at the same time to reduce the cost of measurements, to reduce the cost of protection equipment, and finally and foremost important is the safety to stop operating. This is a very essential. If the instrument fails or burns, we can replace it, we can purchase it. But what about the operators, linemen or jury linemen, who is always will measure the values in the substation yard? So, we have to take the careness while taking the readings with the help of high voltage, with the help of the CTs and PTs also. Okay, let us see. Now, instrument transformers are two types. One is a current transformer, another is a potential transformer, as you already know. So, what is this one? This is known as the potential transformer. This is known as the current transformer. Okay, the potential transformer measure the voltage, and the current transformer measure the current. Okay, so current transformer is always connected in series, and this connected in parallel. One should be connected to the ground, and there is a line. Okay, we will see how this instrument transformers connected in our HT substation. You can see at a glance, you can see it, instrument transformers. Now, in this case, this all are, so R phase, B phase and Y phase. These are the PTs. Okay, high voltage PTs. Now this R phase, Y phase, B phase, these are the CTs. Current transformer, R phase, current transformer, Y phase, current transformer, B phase. So it will measure the current in the line. It will measure the voltage between the two lines. Voltage, R phase and Y phase. Okay, so this is the voltages in 220 kV substation, or sometimes we can measure the 400 kV voltage substations. Okay. Now, what is the main difference between the CT and PT? So we will see later the differences, the main differences between the CT and PT. So here at a glance, what is the main difference? So main difference is where we are going to use this type of the instruments, and what are the values it is going to measure. Okay, you can see it. So one of the major difference between them is that the current transformer converts the high value of current into low value, whereas the potential transformer converts the high value of voltage into small voltage. This is the difference. That means our CT, so what you have observed here, CT connected. So what are the connected terminals? The current is connected here, and it will, whatever the line is going, and take this line, this secondary, it will measure the current. The line is going here, whatever this takes the primary, this secondary. Whereas the PT, so PT has the line, it is going similarly connected to the PT, and the PT is connected here to the ground and correspondingly connected to the voltmeter. Okay, here also insulation. So that means the PT will measure the higher voltage to low voltage, and this is given to our instruments. Whereas here higher current, this is maybe 1000 amperes, step down to low current, CT ratio, we can see the CT ratio, that is maybe 1000 amperes is to 1 ampere. That is primary is 1000 amperes, the CT is the 1 ampere correspondingly. It will measure the low range which is connected to 1 ammeter. It will show the current, so calibrated such as that 0 to 1000 volts, 1000 amps. If it comes 0.1 ampere, it will indicate the 100 amperes. If it indicates the 0.2 amperes, it indicates the 200 amperes. It indicates the 1, that indicates the 1000 amp. Such a way that we calibrated the ammeters or voltmeters. Okay, so these are the main basic difference between voltmeter. The CTs measure the current and PTs measure the voltage. Now let us see the CT in detail. The CT, it is construction basic principle and how the CT is connected. What are the precautions while using the CT? So dear students, you have to remember. So this one precaution, it may be asked at any place in your career. What is that question? Wait some time. Okay, now this is a CT. Regarding to the CT, what do you mean? The CT means current transformer. What are the salient points? You can see here. A current transformer is used to measure the current of another circuit. CTs are used worldwide to monitor high voltage lines across the national power grids. A CT is designed to produce an alternating current in its secondary winding that is proportional to the current that is measured in its primary circuit. What is that one? So you can see here. So for example, Here you can see it. Suppose one line is flowing, this is taking the current, again that current may be, so for example I current, that may be for example 100 amperes. I want to measure the current in the line, whether the current is 100 amperes, less than 100 amperes or more than 100 amperes. I want to know this line from source to, so I am from source to, it's a load center. Okay. So I cannot break this line to measure, for measuring up this current in the line. Similarly R phase, Y phase, B phase. Let us take, this is the R phase line. So with help of my instrument, what is that instrument? So I using the CT here. So I can connect CT here such a way that I connected the simple, this is the terms connected here. Here I am going to connect my ammeter, connected to the one ammeter. Okay, so what is happened? 100 amperes flowing in prime, this it acts as a primary. Now the current is flowing in the secondary. So the secondary ratio, CT ratio, so it will mention CT ratio, that is equal 100:1 ampere. So that means here 1 ampere will flows when the current flowing in the line is equal 1 ampere, that is in the primary. Okay, if the current is less than 100 amperes, for example, so instead of 100 amperes, the current in the line is equal only 90 amperes. What is the current in this secondary? This, what is the induced current in that? So that current may be 0.9 amperes only. Okay, 0.9 amperes will. For example, in the line itself with 50 amperes, then it will indicate only 0.5 amperes flows in the line. Correspondingly, so it is calibrated. How the calibration takes place? So here what will happen? Here, so calibrated such a way that, so this is the reading here, and this is the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the 0, 1, that is 100 amperes. So what is the current here? So here I am going to the 100 amperes. You can take the 10. You can say here, this is the, you can take it, this is 10. 10 amperes, 20 amperes, 30 amperes, dash is to up to 100 amperes. So this is a indicate. As we have seen that once it is connected to this one, this is connected to ear, and this is connected to ear, for example connector. What is happen? So once the current is flowing through the primary current, instead of 100 amperes it is going the 10 amperes. Okay, then what is happen? So 10 amperes current flowing in the primary, then correspondingly secondary CT ratio. What is that CT ratio? 100:1. Okay, 100:1 CT ratio. So if current is flowing in the primary itself 10 amperes, then we are going to, so 10 amperes flows, then it will goes to the 0.1 ampere flows in the secondary. In second is the 0.1 ampere. Okay, so it is 1 ampere from terminal, for example this is the A and this is the B connected. So here our terminal is the A, this terminal is the B. Once A and B connected to this our instrument, and it is produced a deflecting torque. Already we have seen TD, deflecting torque, and due to the deflecting torque the pointer will move at the same time, and controlling torque and damping torque opposes this deflecting torque. Once the deflecting torque and controlling torque, these values are equal. The pointer will stable at one position. One position. What is that position? So that position is nothing but here only it indicates that it will stable at 10 amperes. The pointer will goes stable at 10 amperes. So dear students, have you observed? Actually, what is the current flowing here? Only 0.1 ampere only. But we calibrated such a way that it indicates the 10 amperes. So actually, what is the current flowing in the primary? 10 amperes. What is the indication of this here? 10 amperes. It is over. Such a way that we can utilize it. For example, this line, so which is flowing, is a 50 amperes. It's a 50 amperes, for example. If the 50 amperes corresponding current flows in the secondary, what is that value? That is equal now 0.5 amperes current flows. Now the 0.5 amperes is connected to the AB terminal, here A and B terminal, then it indicates the 0.5 amperes. Now the deflecting torque produced in this case is now more, and deflecting torque will try to move the pointer up to the 50 amperes. Then it is stable at 50 amperes. So we are going to read it 50 amperes. Same current is flowing in the primary, such a way that we are calibrated our instruments. Okay, so actually the current is flowing in our instrument is a 0.5 amperes only, but indicates is a 50 amperes. That is the real current is flowing in the line. Suppose if goes the 100 amperes current, then correspondingly 1 ampere current flows in the line. So deflecting torque is developed as more, and the pointer will shows the it's a 100 amperes here. Dear students, please understand this operation. How it is simple? So these instruments are used in our electrical field for measuring purpose. Same value is given to the our protection also. What is the purpose of protection, sir? So here, what is that one? Here house is taking the maximum 100 amperes. Okay. Now, for example, the line fall on the ground. Instead of 100 amperes, the current may be flows in the fault area 1000 amperes. 10 times current flows. If 100 amperes flows through the line will burn out first of all. Burn out. Why? So heavy current flows, that is equal I square or T by J. Heat will develops, the heat will burn the insulation of these all materials. Total will collapse. So what to do? So whenever the current flows more than 100 amperes, the current which is flowing to the fault point should be avoided by connecting the one CB, circuit breaker, CB. So the circuit breaker, whenever the current flows more than 100 amperes, automatically the switch will open. That indicates that no current feeding to the fault point. Now, how to operate this circuit breaker? To operate circuit breaker, we require the relay help. How the relay will works? Based on our CTs only. So this is an interlinked system. Okay. So here what has happened? So here the line, which is you can see, dear students, it's a line, and before here line I am going to use the one. I use the one CB circuit breaker, that is just like a switch, and this can be operated with the help of our friend. Who is the friend? CT. Okay. Now the CT CBs are placed in a substation yard and this ground. Now it will always measure the, just like the CT will measure the what is the current in the line. If the current in the line is a predetermined value, that means whatever the line is predetermined, for example 100 amperes. So if the 100 amperes flows, correspondingly it indicates in meters and 100 amperes. At the same time, another terminal is connected to the mechanism of this one through relay coil. Relay. What is the here? So once the current 100 amperes flows, it will indicate the 100 amperes, and the same 100 amperes given to this circuit breaker, and circuit breaker understand that, so this 100 amperes is the rated value, no problem. If the line fallen on the ground, instead of 100 amperes, the current is flowing the 500 amperes, for example, assume it. Then correspondingly CT ratio, more current will flows and relay will operate. The relay will give the signal to the circuit breaker, just you open the circuit. Instead of closing, it open the circuit. Once the circuit is opened, no current is flowing to the fault current. Such a way that this line is protected from overcurrent whenever the fault occurs in the system with help of our CT. Okay, so that means it is used to measure what is the current in the line, as well as it is used to give the relay, which is the relay will help to operate the circuit breaker. Circuit breaker is nothing but it is a mechanical device which can isolate the circuit under normal condition, under abnormal condition without any problem. Okay, that is the help of CTs. So that means CT can be used two purposes. One is the metering purpose, that is the how much current is flowing in the line, metering purpose. Another is the protection purpose. Protection purpose. Now you have seen how the metered, this is indicates. So while it is a indicator 100 amperes, it is a indicated 100 amperes with help of the CT. At the same time, protection, when the fault occurred, the current is nearly 500 amperes, that is indicated with the ammeter. So once 500 amperes flows, automatically breaker will trip instantaneously. So that is given to the protection also we are given to the line. The same CT, so we can use for the metering purpose and protection purpose. Okay, the CT is nothing but, what is this one? It is how it is connected. So simply the current transformer also consists of the two windings, namely primary and secondary. So this is the winding, this is a line which is act as a primary, and the line which is act as the secondary. So this is the secondary, this is the primary. Okay, primary line, this is the secondary. The current transformer is basically a step up transformer. It is a step, it is a single turn, there is a more turns in the secondary. Step up current. Okay, step up transformer. And it works on the principle of the primary MF and the secondary MM. What is the meaning? Here the primary wind is what is the number of turns? N is equal to 1. What is the current? I1. What is the secondary current? It is having the N2 turns. What is the current here? I2 current. So these values are secondary currents, these values are primary current, primary line. Now, so it works principle of MMF. So magnetomotive force. What is that one? So here the N1 I1 of primary equal to, okay, so primary MMF of equal to the secondary MMF. What is the secondary? N2 I2. Okay, so this is the primary, this is the secondary. So this is the formula. So MMF magnetomotive, so force MMF of primary equal to the MMF of secondary. Okay, so that means it is a step down transformer. Voltage will step down. Current also step down. So here 100 is to 1. That means 100 amperes step down to 1 ampere. So what is the meaning? So flux, nothing but MMF is another flux. Flux of primary, flux of secondary. Connected here. Okay, it works on the same principle as that of the ordinary power transformer. Same power step up purpose, step down purpose we are going to use. The low range of ammeters 0 to 5 amperes is connected in the secondary side of the current transformers. So here I am going to connect one ammeter here. So terminals, this is the ammeter having the terminal here, this one are connected here. The ammeter is calibrated to read the high current, or it will provide with a multiplying factor. So otherwise we are going to what will happen? So we have seen 0.1 ampere indicated as a 10 amperes. Such a way that we calibrated our small meters. Or sometimes we can indicate the 0.1 ampere only, but it has the multiplication factor MF. So we multiply with 100, then we are going to the 10 amperes. Whatever the indicates into multiply with the MF, so we are going to the same value. So both types we can use in our electrical field. Okay, so these are some salient points regarding to the CT. What happened? Now, so you can see the few CTs used in our electrical field. So these are some okay. So these are the CT, you can see it. So what it consists? It has a tank, okay, is a oil tank. We can say it is placed in oil because continuously current is flowing into the coil, it may be heated. That's why it is the oil filled it. It is the oil tank, it is a primary, and here connected with the secondary. These are the forced insulation. So isolation, this is from ground to isolation. Okay, this is the P1 and P2 are the input and output terminals. Whatever the current lines comes will goes. This is the P1 and P2 connected, and it placed in a oil. And now, so I used, this is a secondary connected here. So it is placed in forced insulation base. So it connected to the terminal. This is given to the our metering purpose or protection purpose. Both purpose we can use. Okay, so the basic principle. Now you can see the practical machine. So this is a one practically used in our substations. Now you can see the optical current transformer, latest one used in nowadays. So it works on the optical based on the illumination. So you can see it. This is a optical CTs. The purpose is same, but is the latest we have used the based on the optical current transformers. Okay, so these are the some transformers. How it will works? Let us see one second basics. Now you can see there is a supply, there is a load. Okay, so phase neutral is going, supply is coming in this side and load is connected here. It is going to the some load is going to some here. Now the line which is a neutral, this is a phase. The phase is going to the transformer primary. The what is current flowing here, and it induces the flux here, and linked with this one, it induces the EMF in this one, and the current is flowing here, that is connected to the small ammeter. Okay, that is a current transformer. Yes, we have seen already. Now based on this current, the flux induced also changes. If more current flows, more flux, more links, more current induces. Correspondingly, we are going to show calibrated the ammeter. That is already we have seen. And you can see the another also here. You can see it. The primary current, which is the primary current is flowing, and there is a, you can see this as secondary, We can say this is a toroid without any core material, toroid. The toroid which is not contacted physically with the primary conductors, just like the clamp meter. Okay, the conductor is not electrically contacted, it is in between only. Then what will happen? It will act as a primary, it will act as a secondary toroid. And the toroid having the secondary current which is connected to the terminals, the small ammeter. Then ammeter will indicate the value. Okay, dear students, once again I am going to explain it. Please listen it carefully. What is that one? So this primary current, the conductor which is flowing current under normal condition, for example, so it is designed for the 100 amperes, and CT ratio, this ratio is designed for the 5 amperes. That means whenever this current is flowing 100 amperes, and our CT will gives the 5 amperes. The CT ratios may be 100:1 or 100:5 amperes, or sometimes 100:11, 100:55. So what is this one sir? So one is given to the measuring purpose, one is given for the protection purpose, for relays. Okay, you can see then power system. Now in this case, so we are going to use that means the primary is the same, secondary is the 2 coils. One coil is given to the protection purpose, one coil is given for the measurement purpose. Now what is happen here? For let us assume this is only metering purpose. 100 amperes, whenever the primary current flows 100 amperes, secondary current is the only 5 amperes. So here the current is flowing now in this case at present 50 amperes only. So what is the flux produced in the primary is equal to, what is that one? So 1 turn into 50 amperes, that is equal 50 mmf Webers. Now secondary, you can see the N2 number of turns and correspondence current. CT ratio 5 ratio. So whenever the 100 amperes flows, 5 amperes develops. If now 50 amperes flowing in the primary, correspondingly what is the current? 2.5 amperes only flows. So 2.5 amperes flows in the secondary. What is the mmf? 2.5 mmf into N2 number of turns here. So this value is equal to this value 1 into 50 amperes. So always it produces the flux, is the primary flux, is the secondary flux. So in this case the primary flux always is greater than some of the difference flux will flows through this ammeter and indicates values. That's why the secondary mmf always opposes the primary mmf as per our Lenge's law. Okay, now what is happened? So difference of that one, same, some difference will flow through this ammeter, and the ammeter is calibrated such a way that it indicates the 50 amperes in small ammeter. Okay, that is the principle of operation, this one. Okay, now